SMPTE 2110. What's it all about? The 7 layers of the OSI model. SMPTE 2110 is bringing a change to our industry. Many of you are traditional broadcast engineers, and leader products have traditionally been used by yourselves with the prime responsibilities for the technical aspects of transmitting broadcast media. You work with specialized hardware and software that deal with the video, audio and ancillary data, ensuring high quality transmission and reception. And you'll be familiar with products like the leader 5300A. IT network engineers, on the other hand, focus on managing local area, LAN, and wide area networks, WANs. Their work primarily revolves around routers, switches, firewalls, servers, and other network equipment, ensuring data flows smoothly across the network and resolving issues related to connectivity and network performance. And tools like Wireshark are used to analyze packet captures on networks. But we're now moving into a world where we have a hybrid broadcast stroke IT network engineer. And they're responsible for integrating and managing both the traditional broadcast systems and modern IP Internet Protocol based technologies within a media production environment. And as the broadcast industry transitions from serial digital interface, SDI, to IP-based infrastructures, these engineers ensure seamless interoperability between legacy equipment and new IP systems, which means they need test and measurement products that are capable of analyzing both traditional SDI as well as IP-based infrastructures. And fortunately at Leader, we now have 3 products that fall into this realm of being able to work with both SDI video and IP. The migration from SDI to IP and the 7 layers of the open system OSI model. So as many of you will know, there's well documented 7 layers to what's called the OSI model, starting with layer 1, the physical layer, layer 2, the data layer, 3, the network layer, 4, transport layer, 5, the session layer, 6, the presentation layer, and 7, the application layer. So in a world of 2110, we have our camera and our data will migrate all the way through the system to the physical layer, where it will pass through the network switch, and then it will do the reverse journey back to the receiver. So let's take a look at what goes on here in a bit more detail. And we'll start off with layer 5, the session layer. And this manages the establishment, maintenance, and termination of connections between applications. So as you can see here, information for each layer is described in the header. So the session layer has an RTP header along with the payload. And on the leader LV56 and 7600, we can display the RTP header information in real time, and it will indicate the payload type, sequence number, timestamp, and source identifier. Layer 4 is the transport layer, and this uses a UDP header. And now you can see here that this has been added. And again, the 56 and 7600W can analyze the user datagram protocol, UDP, which is a connectionless protocol used in networking. It is commonly used in applications where speed is more important than reliability. Layer 3 is the network layer, and the network layer is responsible for logical addressing and routing of data packets across the network. And here, the IP header is added. And again, the LV56 and 7600W can display the IP header, which is meta information at the beginning of an IP packet. It displays information such as the IP version, the packet's length, the source, and the destination. Layer 2 is the data link layer, and this handles the reliable transmission of data frames between adjacent devices across the network. And here, the MAC header is now added. The LV56 and 7600W can display the MAC header, which is a data field added at the beginning of the network packet in order to turn it into a frame to be transmitted. And now we're down to layer 1, the physical layer, which deals with physical transmission of data bits over the network medium. And protocols include the Ethernet. So where does SMPTE 2110 fit in? We have the 7 layers of the OSI model, and these are already used by well-respected industry bodies, and they have created standards that SMPTE 2110 is going to be based upon. So let's start off with the physical layer and the data link layer, and they've been developed by the Institute of Electrical and Electronic Engineers. Then we have the network layer, transport layer, and session layer. And we're going to be using standards that have been developed by the Internet Engineering Task Force. And these are extremely well established, with the transport layer, RFC 768 UDP user datagram protocol dating back to 1980. And the newest on there, RFC 3550 real-time transport protocol in the session layer, dates back to 2003. So, layer 5, session layer, payload header, the SMPTE 2110. And here on the LV56 and 7600, we display the extended sequence number, data length, field ID, data number, continued bit, and offset in the payload header information. We also display SMPTE 2110-30 and -31 and -40 ancillary data. We can also display the payload header for SMPTE 2022-6 and the payload header for SMPTE 2059 PTP. Link Layer Discovery Protocol, LLDP. Link Layer Discovery Protocol is a link layer protocol used by network devices to advertise their identity, capabilities, and neighbors. The LLDP info instrument is particularly useful as an in-band method when you need to identify the port and device to which the user is connected at the end of the wired Ethernet link on a local area network. And this is available on the Fabrics QX, QXL, QXP, and Leader Fabrics LPX500. When enabled, LLDP sends and receives the unit searches for neighboring LLDP-enabled devices connected to either the SFPs or the management port. The unit reports the following data items: system name, system description, chassis ID, port description, management IP address, and primary VLAN ID. So as you can see, the Leader products are not just your traditional broadcast engineering products. They now also present in real time IP information that is pertinent to an IP network engineer. And products such as the LV7600, 5600W, QX, QXL, QXP, LPX500 and SX tag are giving hybrid IP and SDI broadcast engineers the tools to navigate and deliver outstanding quality with these new SMPTE 2110 systems.